This video will demonstrate the basic differences between a double scripted array, a two-dimensional array, and a double pointer. To start off with, I will quickly tell you what happens in the background when you define a double scripted array. So when you declare an array, let's call it A, you tell it what the size of this array should be. You need to know the size of the array. And that's really the reason why we're going to do double pointers, because we don't know the size. But if you know the size, you just declare an array as normal. What then happens is that your computer takes a chunk of memory and it subdivides it. What this says is, I want 2 rows with 3 columns. So when you declare an array, it says we have 2 rows. So we split up a chunk of memory into 2. And basically, this is an integer, so we have 2 times 3. It's 6 elements in the array. 6 times 4, because an integer is 4 bytes, that gives you 24 bytes. So you need 24 bytes, so it takes a chunk of 24 bytes. This declaration does. And then it says I have 2 rows, so separate it with 2, and then I have 3 elements in each row. So in essence, what happens is that this will be A0, and I draw this in a block to show you that it's a one singular block of consecutive memory space. A0, 1, A1, sorry, that's A0, 2, like this. A1, 0, and A1, 1, A1, 2. So those are all the 1, 2, 3, 4, 5, 6 elements in this array. Now, what is important to understand here is this here has an address, and essentially, let's just assume that this is address 3000. This here is address 3004. This here is address 3008. This here is address 3012, 3016, 3020. That's how C will allocate memory. It'll go and find memory, and then it'll use this 3000. When it founds it, it's the first element there. So when you print the following, when you print A, what will print out is 3000. When you print A0, what will print is 3000. And that's important to note. So A0, just if you were to pretend that this is one single dimensional array and you print A0, it'll print 3000. Also, if you do ampersand of A0, 0, so that's element's address, it'll also print 3000. If you print A1, it'll give you 3012. Why? Because this is the first row, this is the second row. Look, we've left out the second dimension here, telling you which column. Its address is 3000, that's where it starts off at. The value at A00 you can set, so A00 we can make equal to 0, and that then goes and makes that value equal to 0. That's what this line of code here does. So what this essentially does is it says go to row 0 and then get access to element number 0. If this was A1, it says go to row 1, get access to element 0, for example, make it equal to 1, that'll make it equal to something more useful, make it equal to 3, and that'll put a 3 in there. If you write it down, and this might help some of you understand it, you can even write it down like this. So you can make it A1, put it in brackets, and then put the 0 there. So that's really saying dereference go to row 1, and then dereference go to element 0, make it equal to 3. These two things will do exactly the same. like that. Okay. You can also dereference it as such. You can say, so let's just look at this here quickly. An equivalent of that is saying A0, and then you want to access one of the indices. So we're saying plus 0 dereference. It's just the same thing as doing that. If you don't get it, don't worry too much. It's not that important. If you don't know the size of the array, we're going to do something else now. If you don't know the size of the array, then you specify a double pointer, and this is the way that you do it. You say int double pointer, let's call it b. So what happens now, and I want you to, as I go through this, think back to the memory allocation here, right? One line, one block, one line. It's just one block of memory. And the thing that I also want you to keep in mind is if you print out A, it gives you 3000. That's just an aspect that C gives you. That's what C gives you for arrays. If you're working with this, we're going to now make a variable size array. So we're going to abuse double pointers to make us a variable size two-dimensional array. What happens if you do this is C goes and makes a variable of 4 bytes. It calls b, and this variable is a double pointer. So it will point to something which will point to something else. That's what a double pointer means. All right, and this is 4 bytes. So this will exist somewhere in memory. Now the place that this will exist in memory, let's say that is at 4000. Obviously it's not going to be 4000, it'll be somewhere in memory where these 4 bytes will live. What we then do is we say we need to build this. We need to build a block of memory to store the numbers in our two-dimensional array. So the first thing that we do is we say, let's now make pointers. Let's make, how do you say this? Let's construct something that will contain the rows, and then let's fill those rows. So the way that we're going to do this is we'll say b is equal to malloc. So get some memory to store the following. And what we will store is, we will store 2 pointers. I'm just going to use the same notation that I have here. I'm going to make something with 2 rows and 3 elements. So what we do is we say give us some memory. Its size is the size of an integer pointer multiplied by the number of rows we have. So let's say the number of rows was r, that'll be multiplied by r. So what happens here is the computer goes away, it finds, if the rows was 2, we have 2 rows, it'll go find 2 pointer size elements in memory. Each pointer is 4 bytes, so it'll go away and find a block of memory of 8 bytes, and the first part, let's say it found something at 5000. This is just for argument's sake. At 5000, so this will be at 5004. It's now found space here where this double pointer is pointing to. So it found memory, it found it at 5000. It'll put that 5000 here as a value into B. Right, I'll say that again. Goes away, find me space for a pointer which will point to the elements of each row. I need 2 pointers because I have 2 rows. This is size of one of those pointers. Find me 2 pointers worth of memory. It found it at 5000. Put that 5000 into B. So B's value is 5000, i.e. B is pointing here. What we do then is these we want to point to our arrays which make up the elements of the matrix. So the way we do that is we say for I is equal to 0 to I is less than the number of rows, I is less than the number of rows, increment I, And what we need to do now is we need to make these pointers, remember this is a double pointer, so it points to a pointer, points to two pointers in this case. These now need to point to the actual elements. So we're going to do malloc again. So we're saying make bi, which will be that one and that one. You could have also just said b plus I dereference, same thing. Okay, b plus I dereferenced. In actual fact, that might be easier for you to understand, but I'm going to stick to the example on web studies. Bi, so dereference b, get access to the 0th element, make it point to another memory that you're going to find me. The memory that you will find me will be the size of an int multiplied by the number of columns, which I'm going to denote with C. So how many columns do I have in my matrix? I have C columns, so I need C members or C elements inside this array of mine, single array, find memory for it and save it there. What happens on a graphical level, I'll just draw it here. On a graphical layer, we're saying we want each one of these to point to the actual elements in that matrix. So find me 3 elements there, find me 3 elements there, and then store my values of the matrix of my 3 by 2, store it in here. Okay, so I have 3 columns, find me 3 integer value worth of memory in this for loop. So first find that and then find this. So let's say it found this at 6,000, this at 7,000, which means the address here will be 6004, 6008. This address will be 6004, 7004 and 7008. Now we have something that's supposed to resemble this here. This was all nice and linear, with the added benefit that the name of the variable, the name of an array, was the address. Now it's not that easy because we've manually constructed this whole array here. Because we've manually constructed it, we've had to make a pointer called b. We have that pointing to 2 elements, b0 and b1. So the names of it is b0 and b1. And they then each point to an array, a one-dimensional array, which makes up the elements of my matrix. So what I then do, if I print out b, it prints out 4,000. Sorry, if I print out the address of b, it prints out 4,000. If I print out the value of b, it prints out 5,000. Because this is pointing there, its value will be 6,000. Because this is pointing there, its value will be 7,000. So if I print out b dereference, that will go, this is b, dereference it, give its value, it'll print out as 6,000, and that's the same, it's the same as just doing b0. Okay, if I do b plus 1 dereference, it's the same as doing b1, it'll print out 7,000 because this is pointing to the second lot there. Now note, this is how I could have done it, and then the next question is what happens if you do b0, you can write it like this if you want, 0, that says take b, dereference it, get access to the first element that you found, offset of 0, dereference that again, so take that, dereference that 6,000, go there to the 0 offset, which is that one, make it equal to 0. So that'll put a 0 there. If I do b01 is equal to 1, it'll go b, dereference 0 offset, so here 6,000, dereference 1 offset, make it equal to 1, put a 1 there. and the same with B1. If that's B1, so it takes B, dereference it, i.e. go to 5,000 with an offset of 1. So go to 7, get 7,000, dereference that, so go to 7,000 and access the 0th element there. So this here, make it equal to 3. That'll put a 3 there. Same if I do B1 and 2, and I make it equal to 5, it'll go get B, this is B, get it, dereference it, so that's what the bracket does here, dereference it, go here with an offset of 1, so it gets 7,000, dereference that, so go to 7,000 with an offset of 2, 0, 2, 2, and make that equal to 5, it makes that equal to 5. So essentially what I've done is I've emulated this whole, oh, you've missed half of what I've written. I've emulated this two-dimensional array. I've emulated and constructed, built up from scratch using a double pointer. Now the problem comes in when you want to pass this to a function, the two will behave differently. Because if you pass this as a double pointer to a function, the function will not be able to go dereference this and dereference it again, because if it dereferences that A, it gets 0. If it dereferences B, it gets 6,000, which it can dereference again. So if you pass this array to a function and dereference it, you can only do it once. Because the A, the name of the array is just 3,000, and if you dereference 3,000, you get the value there. Because this was constructed with a pointer concept in mind, if you dereference this, you get that 6,000. If you dereference 6,000, you get the element. So when you pass it to functions, you need to be careful. And I'll quickly make a new video to explain how that works in the code. But this is the essence of what you need to understand. When you pass this to a function, you can pass it as a double pointer. When you pass this to a function, you need to pass it as an array, or you need to do funny stuff with the pointer that I'll show you in the code in the next video.